Good morning, good afternoon, good evening, good wherever you are, and welcome to this SNIA CSTI presentation. Today's presentation is on cloud data management and interoperability and our CDMI standard. We're going to tell you why a CDMI standard matters. So, to introduce, my name is Alex McDonald and I'm your host for today, and I'd like to introduce our two speakers today. Firstly, we have Mark Carlson, who is the co-chair of the SNIA Technical Council and works for Kiosia. Mark, is it good afternoon or is good morning where you are, isn't it?
Yeah, still morning.
Still morning. And we're also joined by Eric Hibbard, who is the chair of the SNIA Technical Working Group. And Eric's going to be taking us through some of the security implications of the new CDMI standard. Good morning, Eric.
Morning, Alex.
So just a quick SNIA legal notice. This presentation represents a work in progress and a work of SNIA. And if you use it, we'd like you to, if you wouldn't mind, adhere to the copyright implications as laid out in this slide. The other thing I think is really important to note is that any advice that you get from us today, we're not lawyers, but we do know one thing. If whatever you touch with this thing breaks into two parts, both of them are yours. They're not ours. And that really is the essence of this slide, copyright and making sure that you understand liability for anything you do is yours. Before we go any further as well, I would just like to introduce you to the interface very quickly. The interface allows you to do several things. One, rate us as you're leaving the presentation. If you think this is a great presentation, mark it a 5. If you think we could do better, mark it lower. But basically, we're looking for feedback, and part of that feedback is the comments that you make in giving us advice on what you'd like to see, what you thought of this presentation, and any general feelings you have about it would be more than welcome. We're always interested in understanding how these presentations are received. The second thing, apart from rating us in the way out, you can ask questions as we go through this presentation. And I'll be moderating the session. When the questions come up, I'll make sure that if we have the time, we can interrupt the speaker to get an answer to your question as we move through the presentation. Failing that, you'll find a link at the end of the presentation that allows you to go, and we'll answer all the questions that are asked via a Q&A, probably within the week or so, that you'll be able to pick up from the SNIA website. And last but not least, there are attachments and links that you can get, and the presentation in a PDF form is available for you to download right now. So, what does SNIA do? We're 185 member companies in the storage industry, and we've got about 2,000 active contributing members within the group, and over 50,000 IT end users and storage professionals worldwide. That's you. Now, you're part of that group that we talk to on a regular basis and provide education to. What the CSTI does, the Cloud Storage Technologies Initiative does, is we attempt to educate. So our role in life is to bring to you good quality education material about cloud and cloud storage. We support and promote business models and architectures and various other third-party solutions, like, for instance, and this is just one of them, OpenStack or Kubernetes. We attempt to understand things like hyperscaler requirements and incorporate them into our standards and programs. And last but not least, we collaborate with other industry associations to make sure that we cover all aspects of compute and networking and storage technologies when we're talking about cloud. So, the agenda for today. We're going to be talking a little about the newest in the Cloud Data Management Interface standard, the 2.0 standard. And Mark's going to take us through that and talk about the new features of the latest release, and also talk a little about the advantages of having an open source specification for doing cloudy things. And Eric was going to take us through some of the security implications, of this new standard, and how you might best address the kind of security questions that are becoming all too commonplace these days. It's an unsafe world out there, and we, I think, as an industry, need to pay far more attention to security and privacy than we have done in the past. And Eric's our man for taking us through that. But without further ado, Mark, let me hand the presentation over to you, and you can take us through CDMI 2.0. Thank you.
Thanks, Alex. Well, what is CDMI? It's a cloud object storage protocol. It's an ISO IEC standard. It's maintained by the SNIA, and it's been adopted by the Cloud Storage Technology Initiative that Alex just talked about. And CDMI defines RESTful HTTP operations for accessing the capabilities of cloud storage, allocating and accessing containers and objects, maintaining users and groups, implementing access control, attaching metadata, making arbitrary queries, using persistent queues, specifying retention intervals and holds for compliance, etc. But basically, CDMI gives you knobs for your data. When you put your data in the cloud, how is that data treated? What are the requirements for that data? How fast does the access to that data need to be? Bandwidth in terms of like latency. The standard actually standardizes how a cloud should treat your data. So CDMI is a RESTful API for accessing and primarily managing the cloud storage. The major cloud storage APIs that are out there include Amazon AWS, of course, SNIA, Microsoft Azure, OpenStack, and Google Cloud. And CDMI, at least the previous versions of it, have seen wide implementations. And there's also CDMI gateways you can load into your cloud that will understand what the spinning data does and support it for you using native capabilities. This all started back in 2009 when we started the Cloud Storage Technical Work Group. In 2011, CDMI 1.0 was ratified as a U.S. technical architecture. We went through several Errata releases, and then CDMI 1.0.2 becomes the 17826:2012. We then started working on CDMI 1.1 in 2013, and we had 18 extensions submitted for 1.1. And what extensions are is sort of a delta to the regular spec that says if you were to implement versioning, for example, this is how you would add it to the spec, what technical requirements, specifications there are, what interoperability features there are. And so this is how the CDMI spec evolves. Somebody publishes an extension with the agreement of the twig. Multiple vendors then implement the extension, and that becomes part of the main specification. If only one vendor has implemented the extension, we still put it in an appendix, an informative appendix to CDMI to promote other companies implementing it and become part of the main standard. Then in 2016, CDMI 1.1.1 becomes 17826:2016. We incorporated 5 extensions, and 13 remained unimplemented. In 2017, we started working on CDMI 2.0, and just this year, CDMI 2.0 was ratified by SNIA. There's one new extension. We incorporated 9 total, and 5 of the existing extensions have been updated. So why does CDMI matter? It's very simple and easy to implement. You can start with just HTTP transfers in and out of your cloud if that's all you care about. But then eventually over time, new functionality that's already been standardized. In CDMI, there are very few mandatory parts, which means that you can grow into the standard over time. by advancing their implementation. There's advanced functionality that's not found in other APIs that provides a foundation for these next generation cloud services, such as federation. It's an open industry standard. It's not controlled by any one vendor. There's protection against patents. And it's a well-defined formal standard, which really enables interoperability, testing, and cross-vendor support. And then we've had widespread government support and adoption. U.S. government DISA, Defense Industry something or other, has mandated this for all government and IT environments. So some of the things that CDMI 2.0 standardized is representations of namespaces in the cloud, the regular CRUD operations, create, read, update, delete. We have data, container, queue, and domain objects. We have security, identity, and access control model. Metadata, including client and vendor extensibility. Data and metadata portability between clouds. Serialization is how that's done, and notifications, as well as query. We implemented a versioning extension, and we can also manage file, block, and object protocols into your cloud as well. So CDMI can be downloaded from SNIA's website. Go to snia.org/CDMI. Those extensions I talked about are defined in the second URL there. Those extend CDMI, and we'd love to get more implementations of those so we can move them into the main spec. And so we will be referring to the CDMI specification for the remainder of this session. There's the link to the actual 2.0 spec. So as I mentioned, extensions can be incorporated into the main text once there's multiple implementations. So we did this with 4 extensions for CDMI 2.0, and Eric's going to talk about some of these as well. Delegated access control, encrypted objects, versioning, and JSON transfer encoding. And some of the extensions did have at least one implementation, so they were added to Annex A. So there's summary metadata for bandwidth. There's expiring access control entries. There's group storage system metadata. There's a header-based metadata extension, which is the way that, for example, AWS does metadata. They do metadata in their header. So CDMI added compatibility with AWS by using those headers. And then there's an immediate query extension added to Annex X as well. We also went and updated some extensions for 2.0. Because these are Delta documents, they need to point to a specific version of CDMI. And so now the data affinity extension, the jobs extension, the capability selection extension, the cross-origin resource sharing extension, and the partial upload extension have been updated external to CDMI. And then lastly, CDMI is open source. It's an open source specification. The GitHub repository is there. You can build it on an open source tool chain. It's based on Sphinx, which allows multiple developers to work in parallel rather than having to lock a common document is what most standards do. So we use GitHub, and then the contributions and issues can be easily submitted by non-SNIA members. So here's our GitHub repository, and here's examples of what are actually a bunch of text files that are built into a PDF file by the toolchain. The README right there on the top of the GitHub repository details how to install the toolchain for multiple different operating systems. And then pull requests can be made as a contributor and approved by the twig. Here's a better look. It's still kind of tiny though. Of some of the text files. We broke down the different sections of CDMI into different text files, so it makes it pretty clear where to go to edit something that you want on a specific feature of CDMI. All right, I'm going to turn it over to Eric now, and he's going to tell you about CDMI security.
Thanks, Mark. So, as you've probably seen in some of the materials that Mark has already presented, security has been an aspect of CDMI from day one, and many of the enhancements, updates for 2.0 are security related. So just as a bit of a recap on some of this CDMI security functionality, I'll just run through basically the mandatory pieces as well as some of the optional elements. So first and foremost, there's a requirement for the use of TLS, and this secures the communications link between whatever client you're using and the server-side implementation. This was deemed as a critical element, and over time, and we'll talk a little more about this, the SNIA has multiple storage management oriented protocols that have been developed, and to ensure a level of consistency and compatibility, the requirements and recommendations around TLS have in themselves been teased out of these specifications and into its own document. So this is a critical component of CDMI, and something that, because of the work that SNIA has done, essentially developed a TLS profile that over time can be adjusted, to reflect the threat landscape. The second mandatory piece is the concept of capability queries, and in particular, a set of security-oriented capability queries. And as Mark indicated, many aspects of CDMI are optional. So from a security perspective, these capability queries are mandatory to implement, so they're always there. And it gives one the ability to essentially check to see what kind of security functionality a particular implementation has, so that you can make a risk-based decision as to whether you're going to use it or not. So if you basically connect up with something that has almost no security functionality enabled, you might want to, depending on the nature of the data, if it's a cafeteria menu, you're probably not going to worry about it. But if it's sensitive or regulated data, then you're going to want to look very closely at what's actually been implemented and activated, on the server implementation you're dealing with. Now, those capability queries correspond to these optional elements that include authentication and access control, data integrity and authenticity. There's cryptographic support, so think encryption, for example. Deletion, sanitization. So how do you make data go away? This is an area of lots of concern. It seems to be a lot easier to record data on storage as opposed to making it go away in a form that forensics people can't recover. And then last but not least, retention, immutability, and holds. And this area was particularly interesting to include early on in CDMI, where the retentions and holds are actually two separate functionalities. So you can actually set up objects that that will be retained for the 3 years and 2 months, and then and the process is basically automated to release those and whatnot. But we recognized early on that there may be a legal matter that comes in that needs to basically override whatever your retention and release policies and settings are. And so this is basically as a parallel mechanism for retention. And once a hold is applied, it actually is, CDMI is designed to not let you release that hold in a sort of a cavalier manner. It takes a lot more effort to turn something off on that. So this is an example where CDMI during its development was very much aware of what was happening in the legal community, because at that point we saw a lot of electronic discovery kinds of activities and the implications for that, and so that was definitely factored into the early design of CDMI, and it continues today. All right, so security also has interoperability goals, if you will, and so this is I think an important list of things that are always under consideration from a CDMI perspective, when work on the specification is underway, and even from an implementation standpoint. Now, again, some of these are optional to implement, but what we're seeing is increased interest in security and data protection, and more of these are likely to be available in individuals' implementations as opposed to not being there. So part of the concepts or goals is dealing with semi-trust of cloud storage. So there are, just because of the nature of cloud, it may not be able to, especially public cloud, it may not be possible to, in most environments, to be able to guarantee fully trusted cloud. But a CDMI is designed to, given certain trust that you may have for your cloud service provider and its implementation, then there's security mechanisms in place to essentially help you realize that. There are, for data, you can actually have mixed security requirements in the same namespace. So it's not a one and done. It applies sort of universally. So if you've got data categories that you're worrying about, where confidentiality might be an issue for some set, others it may be integrity or availability, you have the ability to deal with those kinds of things somewhat independently. Highly regulated data, and you'll see one of the use cases we're going to walk through. This is absolutely one of those medical records where you've got almost every jurisdiction has got their own requirements that you have to deal with, and so CDMI can help with that. The concept of encryption everywhere, so in flight, at rest, is something that's core to the specification. And again, this is the part where it's prudent to check to see what support is in a particular implementation. So centralized and federated key management and identity management are either included or compatible. In the case of things like key management, a lot of work has been done around the OASIS Key Management Interoperability Protocol, or KMIP as it's known, which is a key management protocol that many of the storage industry vendors have also adopted for their storage systems and whatnot. So again, and because of the way it's implemented, it's very compatible with TLS and RESTful interfaces. There's also auditing and access control that can be performed and handled by data owners. So it's not just in the hands of, for example, your cloud service provider. And the possibility for break the glass procedures. So if everything goes wrong, do you have a way to get in and deal with sort of those what could be human disasters and other kinds of problems. All right, so I mentioned the importance of TLS. Like CDMI 2.0, which has gone through an approval process and is underway in terms of updating the ISO standard associated with it, there is this transport layer security specification for storage systems. We have recently updated that to the 2.0 version. But there are multiple previous versions that have existed or to exist. The changes for this specification is really driven by what's happening in the threat landscape. And usually there's some sort of a black swan event that something becomes known, there's an attack or something of that nature that forces the discontinued use of certain protocols, and we've seen that with secure socket layer SSL, and now we're seeing that happening with certain flavors of TLS as well. So the link that you see under the sort of the first major bullet there, that's the link that you can go and see what the previous versions of the TLS spec were. And the 2.0 of the spec is currently out for public review. It's a process that the SNIA goes through. And then once that process completes, you'll see that this new version of the TLS spec will show up on the main page. And then we will begin the process of updating the ISO 20648, which is essentially the TLS profile for storage systems. Now, in this update, so what changed? Well, TLS 1.2 is mandated, and now TLS 1.3 is permitted, and there is actually some specific requirements if you're using TLS 1.3, as well as the existing requirements for TLS 1.2. Equally important, TLS 1.0 and 1.1 are now deprecated. In other words, to comply with the spec, you not only don't use them, but they're not available. So, for example, if someone were to do a security scan on your TLS configuration associated with CDMI, if it lights up TLS 1.0 or 1.1, you are not in conformance with this part of the requirement. That's what that really means. There are mandatory cipher suites. So cipher suites are essentially the way your crypto is bundled up. And there's some recommended cipher suites that, as we've seen over time, this is where sort of the action is for changes. So we're seeing a lot of authenticated encryption, perfect forward secrecy kinds of things are desired now, and so this is where a change in what cipher suites should be used or are required to be used will come into play, and you should expect to see in the future adjustments there. I think the next major revision, so like the 3.0 version of this, will be essentially a transition to TLS 1.3, which is on the event horizon, but probably not imminent. You probably have a year or so to go on. There were some changes to certificate validation. The CA Browser Forum, which is an organization that oversees things like certificate issuing and PKI, things of that nature, they've essentially dialed down the amount of time that certificates can be valid for. So it started at about 3 years, then dropped down to about 2 years, and now it's roughly a year with some transition time. It's like 390 days or something like that. So you're going to see, this is going to be, I think, a source of some pain for organizations that are a little sloppy on their certificate management, because the browsers will be definitely paying attention to these validation periods. Another change is around the use of self-signed certificates. Many vendors will ship a self-signed certificate with platforms, and that's really being discouraged by the IETF. And there's a concept of pre-shared keys, and there's cipher suites to do that. So this helps deal with environments where they're basically closed off. They're not necessarily able to access infrastructure, to do validation of certificates, and then you basically have a failure because you couldn't do that validation. You can't basically reach out and say, is this certificate still good? This allows you to use another mechanism, but you have to share the keys in advance. All right, so this is a pretty major change in the TLS requirements. And as I mentioned earlier, it's one of the two mandatory pieces. And so this update coincides the CDMI 2.0 release. And so this is something that has been carefully worked between a couple of activities within the SNIA. All right, so new CDMI. So the question is, what if you don't want to use the cloud, but you want to use the cloud, but you don't trust the cloud? What can you do? So one of the concepts that's been basically introduced is sort of expanding on encryption, and encryption basically at the object level. And this is designed so the encryption can basically be handled, controlled by the client. So what ends up showing up on the cloud is ciphertext. So the cloud actually, if you're concerned about rogue employees within the cloud service provider, they have no way of essentially getting access to the information that's being stored. And there's also the ability to let the encryption occur at the within CDMI itself. And there may be reasons where you need to do processing, for example, on the cloud, and therefore CDMI might actually need access to the plain text, or be able to essentially retrieve the plain text to present that to whatever applications you're potentially running. So now there's support for basically dealing with both scenarios. And as I mentioned earlier, the KMIP is definitely something that we're seeing being used in conjunction with the encryption. Another area of expansion is dealing with signatures. So this is really a more advanced version of integrity checks. So this is as opposed to a CRC, this is basically a cryptographic-based integrity check that can be used potentially in legal settings if you need to basically give some assurance that no, this object has not been touched from when it was originally generated. The next one, which I find quite fascinating, is the concept of delegated access control. And you'll see in the use case scenario where something like this can essentially be very, very powerful. So this access control allows you to essentially avoid a situation where everything has to be centralized. So you might actually have a scenario where you've got a multi-cloud kind of environment that is sort of loosely coupled, maybe not even quite federated, and this is a powerful way of dealing with the access control, that essentially you could have the various clouds controlling its part of the access control given some set of policy that's been established in advance. So this is an interesting feature that we haven't really seen a lot of this show up in some of the other cloud implementations. I talked a little bit about some of these already, but talking a little more about, for example, the object encryption. The AES GCM is the encryption algorithm, if you will, that is being used. This is actually important because GCM does give you perfect forward secrecy. It's authenticated, and it's fast. So when we were doing work in some other protocols, GCM was selected many years ago because of the ability you could, in theory, handle GCM encryption at the 256 bits of encryption at very high speeds that other forms of encryption, like CBC, for example, you would not be able to keep up with it. The crypto would essentially become the bottleneck. There's also key wrapping that's been incorporated in this release. So you have standard AES key wrap, but you've also got the RSA optimal asymmetric encryption padding included, as well as the key agreement with elliptic curve Diffie-Hellman ephemeral static. And there'll be a quiz at the end to make sure you know what those are. But so those are common forms, but we see AES key wrap is one that a lot of organizations will use. But the thing to keep in mind is you do, in many cases, need some options because not everybody is perfectly aligned on one particular key wrap mechanism. Obviously, you've got support for HMACs, and we talked about digital signatures. So there's a couple of different forms of digital signatures that are being permitted. Again, options are good. This gives you what we call crypto resiliency. So if one of these turns out to be vulnerable, hacked, disallowed, you have options to deal with that. And we talked a little bit about the delegated access control. The mutual authentication in this case is with the X.509 certificates. A lot of that's going to come out of the TLS connections. So you essentially have the ability to mutually authenticate the clients and servers as part of that mechanism. Okay, so we're going to spend a little time talking about a use case. There's a link on this slide. There was a break talk given a few years ago that was very early stages of what could we do with CDMI in a healthcare setting, and this use case was what was constructed to talk about a fairly nasty set of problems to see if CDMI could deal with it in its form at the time, or if it needed to be enhanced. And what you're seeing in the 2.0 is the enhancements that were ultimately identified have been incorporated. This webcast that is available, you can actually go view. And if you're interested in this use case, I would encourage you to go do that. Okay, so a little traveling music, so to speak. What are we dealing with here? Well, all right. So this is a healthcare problem. We've got a French citizen. Okay, so think GDPR and all of the European Union's requirements around data protection and issues, which are formidable. Has wandered into the United States, is hanging out in Denver. And we picked Denver because at the time we were talking about this use case, we were just south of Denver in Colorado Springs. So this individual's got a pre-existing condition, and while on travel, has a flare-up or something occurs that is relevant to that pre-existing condition. All right, so they're out of their normal health environment, and they're in the U.S., which, oh, by the way, brings in things like HIPAA and high tech as a set of requirements, again, dealing with health records. But it's not quite that simple, because what's going on is, you're dealing with a hospital in France. So this is Hospital A is using a service to manage health records, and it's cloud-based, and it's using Cloud A. Likewise, the hospital in Denver, which is Hospital B, is also using a cloud-based service for its records and management of those kinds of things. And so that's kind of the setup. Then so essentially the physician in Denver who is faced with the challenge of treating this patient obviously needs to get access to the records coming out of France. And let's assume that this is not a hangnail kind of thing. This is something that requires treatment. It needs a fairly fast response. To basically the proper treatment is done. For example, maybe allergies or something like that the patient may not be in a good position to sort of talk through. All right. So in this scenario, it became clear that you would need to have some sort of contractual agreement between the service providers, and in this case, think of that as the health provider, cloud-based health provider in France, and the service in the U.S. So that's not all that uncommon. If you're familiar with, for example, Kaiser in the U.S., Kaiser might have an arrangement with a comparable entity in France or somewhere in the EU, and that essentially would describe what kind of data can be exchanged, what's the terms and conditions of how that's going to be protected, and all that kind of stuff. And essentially, you would have to look across GDPR and EU regulations and US regulations, and they would have to come up with some sort of superset of all that. That has to be codified in some sort of agreement for something like this to work. But assuming that you navigate that, then you're away you go. The other piece of this is the medical records are basically going to consist of two components. One is the actual medical record itself, and then there's a whole bunch of administrative stuff, like, for example, billing. It's not like the medical industry is given the service away for free, and that's important because the individuals who would see the different kinds of content is important. For example, the physician is only going to see the medical record component, whereas the billing department in the hospital, there's no reason. In fact, it would be contrary to law for them to be looking at the treatment that was administered, but they would need to know what to bill, for example, an insurance company. All right, so that's why you've got to split that. And of course, last but not least is how to deal with patient consent. So in all of these cases, the patient has basically got to agree to allow records to essentially flow between the various entities to enable this. Now, that's something that can be worked out in advance. So think of this as sort of a out of scope of a CDMI thing, but assuming you've navigated these things, and consent being an important one, and you in fact could incorporate aspects of consent into maybe some of the metadata in CDMI, because it might drive some of the access control kinds of things. Okay. So this gives a summary of so what are the kinds of things that you've got to worry about in setting this up? Well, you got to make sure that the platforms and infrastructure and all the sort of the retrieval and processing, has got to be you've got to have protections against cybersecurity, cyber attacks. We're seeing right now for example, ransomware is definitely a scourge for the healthcare industry. They're getting lots of attacks in that space. It's a target-rich environment, and so because there's a lot of financial information, there's a lot of sensitive information. So this is an area where there's constant probing, constant attacks. So it absolutely has to be addressed. CDMI's got to fit into that kind of an ecosystem, and it can. Obviously, there's data confidentiality issues. So any information that likely would need to move between these various entities has got to be protected. Got to make sure it's not changed on the way, because it could have life and death consequences if somebody goes in and tweaks the data, or even something as simple as billing. If a $500 procedure becomes $50,000 procedure, that could be a source of a serious problem. The separation of duties. This is kind of back to the administrator and the physician are different kinds of duties, and they shouldn't be overstepping what their roles are. Everybody should, anybody touching this data, interacting with this, there should be full traceability and accountability. So authentication absolutely plays into that. Authorization is sort of the second piece of that. The security mantra is trust but verify, or restrict as much as you can. So authorization really helps you sort of get into a least privileged kind of mechanism, and so how that's being implemented is important. And of course, privacy preserving, making sure that the consent, what the patient is willing to let be visible is the only thing that is made visible to the people that have potential access to it. And of course, back to the accountability thing, it's you have logs that let you identify who did what when, but at the same time doesn't necessarily disclose details that are that shouldn't be disclosed. And we've seen instances where for example, something as trivial as a password showing up in a log file is kind of a historical problem. Okay, so this is sort of a pictorial version of what we've been sort of talking about, but you can see here that it is possible to put together a scenario, and it turns out this is not hypothetical. There was actually a company in Europe who has basically implemented this using CDMI and came up and is compliant with the regulations in Europe. So for those of us that work on CDMI and in my case, the security around CDMI, it's been fascinating to see all the trials and tribulations that they've gone through, what issues they had to basically deal with, what questions came in from regulators, what questions would come in from, for example, hospitals, the healthcare, ecosystem. And what we found is that by and large, not a huge number of changes were actually required in CDMI. So one of the ones that I particularly love is, so you can have sort of this object-based encryption and delegated access control. And one of the extensions, you can actually set up the access control so it actually has a time to live. So remember the scenario where you're bringing down records from France into a hospital in Denver, there's no reason that those records should persist in the Denver ecosystem once that patient's treatment is basically done, and they've processed whatever they need to process. So one of the extensions is you can actually set a time where that object, they may still have it, but the ability to decrypt it goes away. So you're essentially using encryption not only as a confidentiality protection mechanism, you're also using it as an access control mechanism. So they may still physically have the object, well, physically may not be, virtually have the objects in the Cloud B scenario, but they may have lost the ability to decrypt it, and therefore it's not there. Now this is important because the implementation of the encryption, if it's done right, it can be considered cryptographic erasure, which is a sanitization method. In other words, a way of making data go away. And so this is the part where, all right, so if you handed the object down, it's encrypted a particular way, but the keys, the encryption keys used to decrypt it, end up being destroyed, then there's no way that information can be recovered outside of where it needs to be. So these hospital B, C, D, wherever you send these objects, using CDMI, you potentially have the ability to not leave data droppings, as we call them. So again, the Bright Talk I mentioned earlier does go into a lot of detail. There's also a white paper that's been produced that talks about some of this. If this is the kind of thing that you are entertaining or thinking about, CDMI offers an awful lot of useful functionality and capability to implement things like this. And because of the work that SNIA has already done, you might want to take a look at some of those materials. So in this particular case, so what is CDMI's actual role in this use case kind of scenario? Well, it's basically the backbone for how all this health information is being distributed, is being moved around between the hospitals and the health record centralized mechanism, in the individual jurisdictions, and then between the various jurisdictions. And that's pretty powerful mechanism because if you move into sort of the classical healthcare environments, a lot of that is assumed to be centrally controlled. There's still a lot of work underway to try and make it easier to be able to have digital records and have them in a format that they can move, but the mechanisms to enable that movement are really non-standard. And so, if you're operating within, for example, Kaiser I mentioned earlier, then they have no problems moving stuff around within Kaiser, wherever Kaiser is. But if you move from Kaiser to, another service provider, if you will, then things get a little tricky. But again, the other piece that this end-to-end security, the encrypted object extensions and the delegated access control extensions are really, really important for realizing this kind of an implementation. That said, it's important to recognize that to build up an ecosystem like this, it does require lots of additional elements. So, I mentioned KMIP, but there's in the healthcare arena a bunch of other stuff that you also have to pay attention to. So this, for example, integrating the healthcare enterprise, that's the IHE, and then the document encryption, you may actually have to deal with some of these and in other aspects. So the CDMI has to be able to cohabitate with these other standards and specifications that exist, but what we're seeing is that in fact CDMI is able to do that. So, and again, as I said, if you're interested in this particular use case as a security professional, I was quite intrigued with the problem set and then ultimately what we were able to do with the CDMI specification. So with that, I'll turn it back to Alex.
Thank you, Eric. Thank you, Eric, and thank you, Mark, as well. Just a reminder that the ISO IEC 17826, which is the CDMI standard, we're continually working on it, so there's an update underway, and you can get involved without being a member of SNIA. So the working group is open to non-members as well as members of SNIA to contribute to the continued development of this standard. You might want to consider as well the advantages in doing things like CDMI for multi-cloud, which is an area I think that CDMI has a terrific amount of strength, and the other cloud APIs don't necessarily have the same richness of capability that CDMI does. The CDMI reference implementation, we're going to match up to the CDMI 2.0. In fact, I think that may already have taken place as the reference implementation matches. So, after this webcast, what can you do? Well, first of all, rate us on the way out. Remember to do that. That'd be really helpful so that we can understand whether we're doing the right things here in terms of the education that we provide. Please rate this webcast, provide us with feedback. A copy of the slides is already available through the interface, through the attachments and links, and we'll also post up more information on the Q&A blog that you'll find the link there on sniacloud.com. And you can follow us on Twitter as well. And last but not least, because we love links and we think they're very helpful in a cloud environment, lots of links. You can go out there and look at various pieces of specifications to do with CDMI. There's the mobile and secure healthcare piece. So there's a variety of information there that you may want to go and look at. If you need any help, please get onto the website and let us know and send us an email. We'll tackle any questions that you might want to raise and any issues you may have. For the meanwhile, though, I'd like to thank both Mark Carlson and Eric Hibbard for a great presentation today. I thank you for attending. Please rate us on the way out. That's the thing I would really ask of you. And for the meanwhile, have a good day and see you again. Bye just now.